Hello and welcome to Mr. Wiley Teaches Math. Today we're going to talk about symmetry. There's different ways to think about symmetry. We can think of it as rotational symmetry, where we take a shape that's the same size and rotate it around its center point and see how many times it overlaps. 1, 2, 3, 4, and we're back to our beginning. So we rotate it. We had rotational symmetry. We saw that it overlapped 4 times. Or we can think of it as mirror lines. And how many times can we divide the shape so that we have two sides that can, if we overlapped it, if we folded it, it would overlap itself. If we took this original and we folded it, we could fold it down the center. We have two lines that line up with each other. So we have one line of symmetry here. Because it's a square, we're going to have another one that goes across this direction. We're also going to have two that go through the angles. So we're going to end up with 4 lines of symmetry in total. Each of these, if we folded it, took the original shape and folded it, we would end up with 2 halves. You can't fold very well. 2 halves that overlap each other. In this case, you end up with 2 triangles. And the thing with overlapping is that we don't have any extra bits sticking out, and we don't have any pieces that aren't covered. It's not like if I turn this angle a little bit, it's not like I have little bits that stick out or that I have little bits that aren't covered. In this case, all the bits were covered, and no bits that were uncovered. So I have 4 lines of symmetry when I think of it as a mirror. Also end up with 4 lines of symmetry. So that was a square, a regular shape, and ended up with 4. Next we have an isosceles triangle. And if I start to divide it up this direction in any way, I don't get any lines of symmetry. Working from this corner and this corner don't give me lines of symmetry. The only line of symmetry I'm going to find runs right down through here, and I have 1 line of symmetry. So that was an isosceles triangle. The next triangle we have is an equilateral triangle. And I think I see that same line running down the center. So there's our first line of symmetry. I could fold this half on this half. I also have a line of symmetry that runs out through here. Second line of symmetry coming this way, and a third line of symmetry which runs through here. I ended up with 1, 2, 3 lines of symmetry. And that was for an equilateral or regular triangle. And on my last I have this shape, this chevron, and I think I only have, again, 1 line of symmetry. So for the irregular shapes, for the isosceles and the chevron, end up with 1 line of symmetry. There might have been a second one to find of certain shapes. But for the regular shapes, the square and the triangle, I ended up with 4 and 3, which happens to be the same number of sides that they have. So regular shapes have the same number of lines of symmetry as they have sides. So if I had a 10-sided decagon drawn, and it's a regular decagon, I'm going to end up with 10 lines of symmetry. Alright, well thank you for watching. Be sure to check the class website for additional examples in the assignments.